goal for today is going to be, or as we finish up here, we're going to add, subtract, and multiply complex numbers. Here's the one thing I want you to think about when you are doing this. When you are adding or subtracting or multiplying complex numbers, we're going to treat them the same as like terms. The only difference, and this is the only difference, is that when you come across an I to some power, for example, I square, we're going to have to simplify that. So we have to simplify our exponents. But everything else we treat the same. We can combine like terms, we can multiply things to increase the exponents, etc. So by way of review here, the first thing I needed to do is distribute that negative across, and then combine my like terms. 4x minus 3x is simply 1x, and positive 2 plus 8 is 10. So this simplifies to x plus 10. Here, there is nothing to distribute except a positive, but that doesn't change anything. So I get 7x when I combine like terms, and negative 6 when I combine like terms. And lastly, when we double distribute, the 4x times the 3x is going to be 12x squared. And then that continues to distribute, so we get negative 32x. And this here gives me 6x, and this here gives me negative 16. Combine like terms, so our final result is 12x squared minus 26x minus 16. Now, again, we're going to do exactly this stuff, except the only difference is when we come across an I that's squared, we have to take it one more step. But everything else is going to stay virtually the same. All right, so our first few examples we're going to do is just adding and subtracting. So there's nothing special to remember, just treat them like as if they were like terms. So in this case, I have a 5 plus a 1, which gives me 6. Woot, woot. Now I have an I minus 2i, so minus I. And there we go. Now looking at B, notice this subtraction is the exact same as addition. All we do is add the opposite. So I change the opposites inside by distributing the negative. The 5 minus the 1 gives you a positive 4. The I plus the 2i gives you 3i. And we're done. There's nothing further to simplify. Yep. So now we're going to continue, and we're just going to refresh ourselves. Remember that when we're adding, subtracting, multiplying, dividing complex numbers, we're going to treat them the same as if they were just like terms. We're going to combine like terms effectively after we do our multiplication out. The only difference is that whenever we see an exponent attached to the imaginary number, you have to simplify it. For our purposes, we're going to be primarily focusing on I squared. But if you did theoretically see an I cubed or an I to the 4th, then you would also simplify that. So let's take a gander down here. What we're going to do is attack, kill, destroy this in the same way. We analyze it and see right there is multiplication. So instead of combining like terms, I'm going to do double distribution. Some of you think of FOIL, grid method, etc., or a Punnett square if you are a biologist. So we are going to say 1 times 3 is 3. 1 times 5i is 5i. Negative 4i times 3 is negative 12i. And lastly, negative 4i times 5i is negative 20i squared. So let's not discriminate just because it's an I. So I'm still going to combine like terms where I can. I notice that these two are like terms, and they combine to be negative 7i. But here's the big caveat. Here's the one place where it's different than what you're used to. We know by definition, I squared has to be what? Negative 1. So, eyes on deck just to see. All you have to do is this. This changes the sign there. It crosses out and turns the negative 20i squared into a positive 20. Let me just show you real quick what's happening, just so that you can see it. Negative 20 I squared. By definition, I squared is -1, so we substitute. And then you see the double negative there becomes positive, 20 like that. So what's the shorthand? Cross this out, change the sign. Always and forever, always and forever. Now we see that this one here, 3, plus the 20 is 23. And that's just pretty much amazing, guys. We just did that. Good. So when we look at D here, something you may notice is that these are conjugates. So some of you simply say, oh, I remember conjugates. Those are where your final answer would be a squared minus b squared. Now, it is possible for us to do that, and we will get to that. We will be needing to use that shortcut tomorrow when we spend some time dividing. But for now, let's just go ahead and FOIL this out to see all that happens. So the 4 times 4 is 16. The 4 times 5i is positive 20i. The negative 5i times 4 is negative 20i. And the negative 5i times 5i is negative 25i squared. So in terms of simplifying, we see that these guys here are opposites. They just completely drop out. So I don't even need to write those. So Molly observed that this here becomes -1. So effectively it changes that negative 25i squared to positive 25. And now combining like terms here to simply get 41. Not quite the answer to life, the universe, and everything, but we are getting there.